Okay, I'm recording. Fantastic. Okay, so before we get going, on the homework, just real quick again, does anybody want a brief description of increasing and decreasing? Did somebody see my mistake and get really confused? Otherwise, we could just jump right to the homework. I just want to make sure that we're on the same page there because I know that I had messed up and I don't want that to impact you guys. Okay. So if you guys are all good with that, that's totally fine. We can just jump into the homework then. So, jumping into the homework, what questions do you guys have for me? Any questions at all from the homework? Otherwise, I'll just pick one that is pretty.
I have a question.
Sure, Keji. What?
I'm just trying to figure out which one. Hold on. Okay, we'll do 75 first.
75? Great. Okay, 75. So 71 through 75 are all based on one picture. Also, this is the first time that I've taken a picture from the textbooks and uploaded them, and made a PDF out of it. So hopefully this, the resolution was okay when you guys were clicking on it in Blackboard. I myself didn't have a problem looking at it, but that's just because when I was creating it, the images might have been larger on my end. So hopefully it wasn't terrible for you guys, but we'll go through that together. Also, before I get to 75, actually, by a show of hands using the raise hand feature in Teams, I told you guys that I would do a makeup office hours this week if you guys wanted it as a result of me not having one on Monday. So I'm going to have my normal office hours today from 4:15 to 5:15. If I could have a show of hands as far as who would want another office hours, like a makeup office hours tomorrow, I can do that for you, but I'm not going to do it unless, I guarantee have people who want to take advantage of it. So raise your hands if you guys, actually want to come to office hours. Even if I just get one hand raised, I'll do it. I just want to make sure that somebody's going to show up. Okay. All right. So then hold on. I'm just going to go ahead and mute everybody again. Sorry. Okay. So yeah, my plan then is that I'll go ahead and I'll do a makeup office hours tomorrow. It'll be the same exact time that we normally have office hours. So just, 4:15 to 5:15, it'll just be on Thursday this week as well. So there will be one today, one tomorrow, and both will be from 4:15 to 5:15. If for whatever reason you can't make it to either of those and you still want to meet with me, my email is always open for you and we can schedule an appointment to get in there. But okay. All right, so with the boilerplate stuff out of the way, let's go ahead and actually jump into the math. So 75 implies that we're trying to find specific values. So why do I know that I'm trying to find specific values? Well, if I have f of some number, and I just realized I'm not sharing, let me share that. That would make a lot more sense. Sorry about that. Okay. Should be up now. There we go. If I have f of some number, I know I'm going to get some number back. We already discussed that a is your input, right? We're plugging something into our function, and then we're going to get something spit back out. So we put something in, and we get something out in return. And that's what a function does, right? We plug something in, it grinds the gears, does some operations on it, and then we get a different number back out. Okay, so for f of -7, the idea here is that you're plugging in -7. And -7, since you know that you're plugging it in, well, this is a function of x. So that means that your inputs are all going to be x values. So you're just looking, you look on your graph and you say, okay, well, where do I actually have -7? So looking on your graph, and I'm going to really struggle to draw this one, so, just bear with me here, but I know it's going to look something like this here. I'm just drawing the points first, and then I'll worry about graphing it in a second. Okay, so we know that it's doing something like that on the left-hand side of the x-axis. So I'm not going to worry about drawing the rest of it just yet, but we know that it's going to look something like that. Okay, so on the left-hand side, all you were supposed to do, and in the directions I said, if the grids weren't marked, then they were each, each dotted line represented 1 unit. So you were just looking for, essentially, 7 units to the left of the origin, right? F of -7 means that -7 is your input, and if -7 is your input, you're just looking to see what the output was. So you count to yourself, okay, well, 1, 2, 3, let's see. You're counting the dotted lines to the left. So 1, 2, 3, 4, 5, 6, 7. And that's going to fall basically between the 2 points right in here, which you're just looking to see what that output is. And that output looks pretty constant since it's a line. And that should just be, let's see, you just go up on the y-axis until you hit that line. So 1, 2, 3, 4. And you realize, oh yeah, when you plug in -7, you get y is equal to 4. So f of -7 is equal to 4. And we can figure this out literally just by examining the graph. There's no actual calculation that you need to do for this. There's nothing that you had to that you had to plug and chug. It was literally just they gave you the graph, they gave you the input, you just had to locate the output, and it was that simple. I could understand that, this is not exactly the best example. Unfortunately, in the homeworks, all of these questions didn't have marks. Like the x-axes and the y-axes weren't marked. So it made it a little more complicated because you literally had to sit there and count the number of units it is away from the origin. But that's, that was the best question that I could get to really give you guys an example of this. So I apologize, but I was, constrained by the textbook here. So, but yeah, so if f of -7 gives you 4, well, then now you're just looking for the other two, so f of 1 and f of 5, right? So f of 1, again, 1 is your input. So we know that 1 is going to be like right about here. And now you're just looking to see what your y value is when you're plugging in 1. So you count up the number of units, and the number of units that it is, I wouldn't go by my picture because mine isn't drawn to scale. So if you're looking at the homework, assuming you have it in front of you, and if you don't, it's still available on Blackboard. You just count the number of, the number of units up it is in the y direction, when you're at x is equal to 1. So you count and you get 1, 2, 3, 4, 5. So y is equal to 5. And we're talking about essentially this point right there. And so you now know that f of 1 is equal to 5. And remember, this should make sense because we know that when we have this form, you can go back and forth from that to an ordered pair, right? So this is the same thing as AB. So when when they give you some input, you're just essentially looking to see what the output is from that ordered pair. And then the last one, f of 5, I'm not going to go through the process again. We just did it twice. But f of 5, once again, you're just looking to see what the y-axis component is. So f of 5, that just means you're going 5 units on the x direction, and that should give you, what is that, 2? Yeah, so I think f of 5 just gives you y is equal to 2, or f of 5 is equal to 2. Any questions on that? Again, I understand that this one might have been a little bit more confusing than others because the graph isn't marked correctly, or, well, marked at all. But that's why I told you guys at the top of the homework that every unit is 1 unit. So hopefully you guys read that before trying to do these problems. 74, sure. So 73 and 74, I think, are very similar, right? Yeah, so 73 and 74, both, again, based off of this picture, but this time you're just trying to find the intercepts. So this is just your definition of intercept, right? What is an intercept? Like, essentially, that's all you really had to ask yourself when you're trying to solve this. So to find an intercept, the x-intercept, you're looking to see where this crosses the x-axis, right? You're looking to see, well, where this has, a y value of 0. So, okay, if we're talking about intercepts, then it, hit the x-axis. So that's going to hit it at, if you're looking at the figure, and I'll try to draw this as accurately as I can, so please bear with me. I am freehanding this one, so it's not going to look amazing. And then it goes back up, and then it's infinite from there. Okay, so if you're looking at this graph, you say to yourself, okay, if I'm trying to find the x-intercepts for number 73, I'm looking for where it hits the x-axis, right? Because if it hits the x-axis, that's what an x-intercept is. Okay, solid. So we see that at 2 points, right here and right here, it's hitting the x-axis, right? So we know for sure there's at least 2 intercepts. And you know what? I realized I just wrote this all in black. Let me use a different color to really. So at that point and that point, we see that, it's hitting the x-axis. So we know that we have at least 2 different x-intercepts. But there's actually one more x-intercept, and it's not noted by a point, but the points that they showed on the graph are really only drawn to show you where it's increasing, decreasing, or constant. But we see that there's actually one more point that it hits the x-axis, and that's right here that I just marked with the green dot. So all you had to do is, now that you realize, okay, it hits the x-axis at 3 times, there's going to be 3 different x-intercepts. You're just looking on the graph to see when that happens. So the x-intercepts are as follows. The first one is -3. If you're counting, again, 3 units to the left, so x is equal to -3. The second one is x is equal to 4, so 4 is right there. And then the third time that it happens, it's 5, 6, I think it occurs right at 7. So your x-intercepts are x is equal to -3, 4, and 7, which you could write as actual points, because that's what an intercept is, right? If you're talking about x-intercepts, then the y component is 0, right? We learned that by definition. So that means we're talking about the points -3, 0, 4, 0, and 7, 0.
Why wouldn't there be 4 points?
I'm sorry?
Why wouldn't there be 4 points? Because it also, it's the x-axis again after that.
Oh, you're absolutely right. Sorry. Yep. So right here, right? Yeah, great catch. So there's going to be a 4th point, and that's because it is absolutely crossing the x-axis one more time, as Keji noted. So what would that be? And again, you're just going right along. So if the third one was 7, then it's occurring 2 more units after that. So this one's going to be 9. So yeah, we're just going to add 1 more point, 9, 0. Good job, Keji. So yeah, that was all there was to this question. And then for 74, it's going to be very similar, but we're no longer talking about the x-axis. We're now talking about the y-axis, right? So we notice that it's actually only hitting the y-axis 1 time. I'll mark it in red. So it's only hitting right here, and you just need to find out what that point is. And just to do that for you guys, I think that's 1, 2, 3, 4, 5, 6. So this is happening at 6, which means y is equal to 6, or you have the point 0, 6. Everybody on board with this one? Again, all you were looking for is just seeing when the function hits the particular axes. That's the definition of an intercept. Okay. All right. 79 and 80. Sure. Let's go ahead. 79 and 80 are based off of the next graph. So before I erase this, are we all good with 71 to 75? Because I would really hate to try to draw this again. The function here. If we're good with 71 through 75, then I'll, go ahead and move on. Okay. Sounds good. Let's go ahead and clear this then. So moving on to the next one, 79 and 80. So it's based off of another function here, which I will once again try to roughly sketch. So roughly sketching it, we see that we're going to have something like this, where we have kind of a disconnected series, almost disconnected. The function appears like it's not continuing from one point to the next, but in reality it kind of is. And we'll talk about this in just a second once I finish graphing this, but let's see, it's doing something like that. And not bad. Could have drawn it worse. Okay. So this is essentially the function they were given to you, or that you were given. So 79 and 80 says find the domain and range. So as we discussed, domain and range essentially just correspond to domain being all of the possible inputs that you can plug in, right? All of the points that are acceptable for the function to put in as an input. And the range is the list of outputs that you get. So you can think about it as your domain is just all of the possible x values that are going on with the function, and your range is going to be all of the y values that come out of it. Okay, so when we're trying to figure out domain of a graph, we should just read the graph from left to right. Okay, so reading the graph from left to right, and again, this is the more tedious part of this. Once again, you have to count the number of units you are away, right? So let's try to figure out what this point is right on the furthest left, so that way, we know that where we're starting. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 units to the left. So we know that this is starting over here at -9. So our domain starts at -9, and notice that we're starting with a closed dot, right? So that means that we're definitely including that number into our domain. So we're going to start here with -9, and I know that I'm going to be using a bracket because, again, we have a closed dot. Okay, so we go all the way up until we move 4 units to the right, which means now we're at -5. So right here, this is -5. And we go until we hit -5, and notice that we have an open circle, right? But above the open circle, we have a closed circle. So I'm not even going to concern myself just now on what the y value is. But we're going to have to figure out the range anyway, so might as well. Let's see what the y value actually is for this. So that's 1, 2, 3, 4 units down. So this is -4 right here, and 2 units above it, that means this is -2. So this point right here, the open circle, well, this coordinate is -5, -4, right? We can all agree on that. It's 5 units to the left and 4 units down. So -5, -4. And then the one above it is -5, -2. Now remember the definition of a function. We kind of talked about this where we essentially said that a graph is only a function if one input does not go to more than one output, right? You have to go 1 for 1. If you're going 1 input, you're always going to only get 1 output back. Is this breaking the rule here? And the answer is no, right? Because we have an open circle for the bottom point for -5, -4 that is not included in our graph. -5 at -5, -4 is not going to be included. So we don't actually have to worry about this point right here breaking our function. So what we have to ask ourselves is, okay, well, is there any point -9 that we have stopped, that we've stopped including x-axis numbers. So we're going from -5, reading it from left to right. And again, you have -9, -8, -7, -6, and you get to -5, and you might think that there's a problem there, but it just picks back up at this line right here. Well, it's not a line, but this curve, whatever it's going on here, that funky looking thing, right? So we're picking back up at -5, -2. So really, the x values are still pretty continuous. We haven't hit a part where we've said no, there's an x value that is not included here, because again, even though that we have a problem at -5, -4, at -5, -2, we're okay. So -5 is still part of your domain. So you just continue going, right? And now we hit a similar situation once again, where we have an open circle, but because we have a closed circle right above it, that means that we're still including that particular x value. Whatever this x value is right here, which let's figure that out together. I think it's just 2. Yeah, so it's 2 units over. So that means that we're talking about x is equal to 2 here. At x is equal to 2, we're not including the point that's an open circle, but we are including the point that's the closed circle. So we are still moving across our function, and 2 is still included in our domain, because again, we see that we have a point on the function where we get an output for x is equal to 2. So we get an output, and again, we just continue moving along in this direction, and we continue moving along forever, right? So as we see, there's actually no single point on the x-axis starting from -9 that is not included in our function. So we actually have a domain of -9 to infinity. There's no point where this breaks reading from left to right. It seems like it breaks because it looks like, the pieces are not connected, but we don't necessarily have to have them connected for it to still be in the domain. What really matters here is recognizing, and again, I'm going to jump to my example with these 2 lower points down here. What really matters is recognizing that at -5, and again, at x is equal to 2, so when x is equal to -5 and when x is equal to 2, you see that, okay, even though we're not including the bottom point, we're including the point above it, so we still have a value, or we still get an output when we plug in the input of x is equal to -5. And again, same over here, we still get an output when we plug in x is equal to 2. So that's how you know that the domain is still including those 2 points. Before we move on to range, are we okay with this? Does anybody want me to go through that again? Again, the entire idea is just recognizing that you are getting an output and you're only getting one output. So you're not breaking the rules of a function, and for the purpose of domain, because you're getting an output, well, it's included in your domain. Okay, you know my golden rule. I generally take silence as you guys are good to go with this. So if you're okay with this, I'm going to move forward. So this one, again, I'm just going to abbreviate this as a capital D. This was our domain, so this was 79. So our range is going to be similar, right? Our range is now, instead of looking at the possible x values, we're now going to be looking at the y values. And I'm just going to try to clean this up without murdering the graph here. So when I say we're looking at the y values, I mean we're looking at the, from the lowest to the highest, right? So that means we're reading the graph now from bottom to top. We write it from left to right to figure out the domain. Now for range, we're going to read it from bottom to top. So we look at our range here, and I'm going to abbreviate this once again with a capital R. So we're now just going to be looking for, okay, what is the lowest value that I'm starting at? And again, we already found that out earlier, right? We saw that the lowest that this graph ever gets is -4. There's actually, because we have a line or a line segment at -4, there's actually a bunch of points that give us -4 back, but that's okay. We can have multiple inputs correspond to one output. You just can't have one input correspond to multiple outputs, right? If we had this circle filled in right here, then we'd have a problem, right? If -5, -4 was filled in and -5, -2 was filled in, then yeah, we'd have a big problem because we have one input, being -5, corresponding to two outputs. But that's not the case here. Same thing with -4, right? So the reason that we know this is okay is because we get -9, -4, -8, -4, -7, -4. You know, these are all okay points. We're just moving along the graph, right? So the point is that we know that we're starting at the lowest value of -4. So we're going to include -4 because, well, it's included. We see that there's a bunch of points that give us -4. The only point at the bottom that's not included is when we have the input of -5, but that's okay. We can, because other points include -4, that means that we are including -4 in our range. Okay, so we're starting at the lowest value of -4, and now you're just reading the graph upwards, right? Okay, well, is there any continuous pattern here between -4 and then the next piece of the graph? So here's what I'm asking you guys. Do we have any points between, for the y value, do we have any outputs between -4 and -2? Is there anything going on, and I'll draw it in blue, is there anything going on in this space right here? And the answer is no, right? We don't have any outputs between -4 and -2. So realistically, the only output that we have at the bottom is -4. So if that's our only output, well, you can draw this, and we talked about this before about how to notate a one singular point when we're talking about interval notation. You can do it in one of two ways. You can either, if you want to do this, that's totally okay. The more acceptable standard, which I only talked about once before, but I know that I did talk about it. The more acceptable standard is to just use curly braces. So curly braces. And the reason that, again, we know that it's just at the one point is because there's nothing going on immediately above it, right? From -4, well, -4 is included, but what about -3? So we're talking about like this value right here. Is there anything happening at -3? Is there an input that corresponds to that output, -3? And the answer is no, right? Same thing with all of the numbers between -2 and -4, so all those fractional values. So we actually see that our range doesn't pick back up until -2. So we say, okay, well, we're just talking about the 1 point, -4, and we union it with the next interval, which starts at -2. And we know we're going to include -2 because, well, we have a closed circle. So it goes from -2 all the way up until it hits, well, it hits this point here. And notice, and please, this is not drawn to scale. The picture is going to be way more accurate than my picture here. But notice that my arrow pointing to this point, the arrow in black and then the arrow in red. Well, the arrow in black, the point that is notated by the arrow in black, is higher up than the one notated in red, right? So what I mean by that is we're going all the way up to, what's that value? -1,4. So at this point right here, we're at -1,4, which means we're going all the way up to 4 units up for our y-axis, right? And this point down here, the open circle one, well, this one only has a y value of 2, right? This point is 2, 2. So because we're only concerning ourselves with, being able to go from the lowest to the highest, this piece right here, which I'm just going to scribble over in red, this piece over here almost doesn't even matter. And the reason that it almost doesn't even matter is because the range of this piece is already contained in, and I'm just going to scribble over in green, the range of the piece scribbled in red is already contained in this piece scribbled in green. Again, it doesn't necessarily look like it by my picture, but hopefully if you're following along with the picture on the homework, it makes a little bit more sense. All of the y values that are in the scribbled in red part are already contained in the ones that are scribbled in green. It's basically like you're getting, a repeating output, right? Like you're getting, first you get, y is equal to 2 or some point over here, right? We get y is equal to 2 somewhere here, but then we get y is equal to 2 again over here. So because we only get it, because we get it twice, you only have to list it once And yeah, so you just have to think about it as far as, well, even if I'm getting my output multiple times, I only need to list it from lowest to highest one time. So this piece, our highest piece, is right at this point, which is -1.4. But then notice that we have the piece over here in blue, and I can see that this is starting to get really messy, so I apologize. But over here in blue, well, this continues on beyond that, right? We're going even higher than 4 as well. And now you just have to ask yourself, is there any breaks between when we have, from -2 to 4? Is there any breaks in there? And the answer is no. And then you also ask yourself, well, are we getting outputs between 4 and whatever my highest piece is right up here? And yeah, you're always getting some kind of output for this interval here. So we're going up on the graph from -2, and we hit the highest point, which is marked by the blue arrow. And the highest point here is, what is that? 1, 2, 3, 4, 5, 6. So we are at y is equal to 6 at this point. Your output is 6. So, and then from there, it's just a constant line, right? Your output is not getting any larger. The line is always going to be y is equal to 6 from that point forward. So you know that it's not going to get any larger. So this here is going from -2 to 6. And once again, you're including 6 because, well, we see that we are actually including 6. There's, many points that satisfy y is equal to 6. Such, here, 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 so on and so forth, all over that line. Okay. So again, the hardest part of this was recognizing that at -4, your range starts from -4, but there's no other points in the output that connect to it, right? We have that line, that horizontal line, where y is equal to -4. So of course, -4 is going to be an output, but that space just above it, you notice you're not getting any outputs. So, well, if you're not getting any outputs there, then it can't possibly be in your range. Then you go above it and you see, okay, you're continuously getting outputs. And you notice that even though these two pieces, the middle piece and the furthest right piece, even though they're not necessarily connected, you're still getting constant outputs for your y value with no break in between. And that's the important piece here. So we're essentially we're including -4, and then we're going from then on from -2 to 6. Okay. Does anybody have questions on this? I know this can be slightly a confusing topic, so I really want to try to figure out where you guys are having trouble with this so I can address that as best as possible. Okay, so again, we're just going to go ahead and move on then. Does anyone have any questions for the rest of this one? So this picture, as messy as it has been getting, this picture corresponds to 79 through 82. So we just did 79 and 80. I just want to make sure that we're all good with 81 and 82. Because 81 was very similar to the one that we just did for the previous problem where you were given some inputs and you just had to find the outputs. 82 took that a little bit of a step further, right? 82, you had to get, they gave you inputs, you had to find the outputs, and then you had to take the absolute value of their subtraction. So you had to do, a little step further than that. If anybody wants to see that or had trouble with that, I'm totally fine going over that, but that's why I'm asking now before we move forward. Okay, so we can definitely go through that. So once again, what you're doing here I'm not going to do 81 because 81 is just going to be essentially a repeat of what we did in the past example, but 82, so we're supposed to find g of -5 minus g of 5. And again, this is the absolute value of those pieces. So before you could ever hope to do this, you need to figure out what g of -5 and g of 5 correspond to. You need to figure out their outputs because their outputs are actual numbers, right? In this form, g of -5 minus g of 5, you can't do anything. These are not numbers. You can't, subtract them. This is saying that you have an input plugged into a function and you're supposed to get a number output, but without knowing that output, you can't continue. So let's go ahead and look at our graph together. And again, I encourage you to use the one up on Blackboard. So first, let's figure out g of -5. So g of -5, again, just means that -5 is going to be your input. So you're just looking to see what your output is at -5. And luckily, we actually already discussed this, right? We see that at -5, and I marked both of them. At -5, we have 2 points in particular. We have -5, -4, and we have -5, -2. So we just need to see which is the correct output. Well, I'll pose this to you guys. Which one is the actual output that we care about? -4 or -2?
-2.
Yeah, -2, exactly. And we care about -2 because it's a closed circle here. Again, notice that -4, we have the open circle, so that's not included. When you plug in x is equal to -5, you do not get -4 back. You only get -2 back because -4 is not included in your domain when x is equal to -5. Okay? So as a result, okay, sure, we now know that when we plug in -5, we get -2 back. So we see here that g of -5 gives us -2. So great, you already have one number, and we know it's going to be a minus. So we just have to figure out the other value. So we have to go look at g of 5. So looking at g of 5, again, you're just reading 5 units to the right on the x-axis. So 1, 2, 3, 4, 5. And you see what that corresponds to, which it corresponds to a 6. So when you plug 5 in, you see that you get the ordered pair 5, 6, which is right over here. That's this point, right up top. And so as a result, you know that you're going to have the output of 6. So now you can actually solve this, right? You have -2 minus 6, and that just means you're going to have -2 minus 6 gives you -8, and the absolute value of -8 is just +8. And that's it. So all you're doing is, again, you're doing essentially 81, the question right before it, where you're finding the output for a specific input, but you're taking it one step further and you're just doing a mathematical operation after that. So you find the outputs, in this case, -2 and +6, and then you're taking the subtraction of them and then, or the difference of them, and then you're taking the absolute value. Can you scroll down to the range? Sure, yeah, absolutely. The range was as follows. Again, and I'll write this in green. If you wrote the point at -4 as this, that's totally acceptable. I would have that. It just means that, you were determined to leave it in that specific interval notation. I will, again, say one more time that if you have one particular point included in either your domain or your range, and when I say one point, I mean specifically at that point, which we found to be the case for -4, then you would generally use curly braces to show that. But if you wrote it as the piece in green, totally acceptable. But does anybody have any questions on anything that we just talked about, 81, 82? And then, of course, just understanding what we're really doing here. The process for this is just find the outputs based on the inputs, do the subtraction and the absolute value as normal, and then you'd be done. And you can do this with, basically any of these points as long as they are included in your domain and obviously included in your range. Okay, so if there's no questions, I do just want to go ahead and make sure that we touch on the increasing and decreasing question, just so we're all on the same page here, because I know, again, that I made that brief mistake. The mistake lasted like 15 seconds in the lecture video, and then I realized what I had done wrong, so I had to go back and correct it. So I just want to make sure that we're all on the same page with that. So let me go ahead and erase this, and let's go ahead and start again here. So the last question is question 14, and it's from the next chapter, or the next section, 2.5, because that's where it talks about intervals of increasing and decreasing, but you don't have to necessarily worry about where it's from, just that, it is part of the next section if you're following along in the textbook. So I really don't necessarily know how good my drawing is going to be of this, but we'll try our best here one more time. So bear with me for 1 second. Let's see if we can figure this out. So it goes like this. It hits the origin. It goes back up, back down, and then back up forever again. Okay. So we have something like this, and I'll go ahead and mark as best as possible what the points are, just like they're marked on the picture that you guys have. So it hits the lowest point down here of -3, -2. Over here, this point right here is -1, 1. This is obviously going to be the origin, so I'm just going to mark this as 0, but we know that obviously the ordered pair of the origin is 0, 0. Over here, we have the point 1, 2. And last but not least, we have the point down here of 2, -3. So this is absolutely the lowest that it gets. So 2, -3. Okay, so what we have to do is we have to figure out where this function is increasing, decreasing, or remaining constant, right? Okay, so don't be fooled here. I understand that, it might be tempting to say that this is increasing right here. But when we read a function, we're reading it from left to right. So although that arrow is going upwards, and you might think, okay, because it's going upwards, then it's probably increasing. Well, we have to read it from the direction that it's coming from, right? So we see that, okay, if it's coming from the left, then that means that we're essentially going down to hit this point right here, right? We're going downwards to hit -3, -2. So we know that from this point, we're actually decreasing to hit that point, -3, -2. Then the function stops at -3, -2, right? That's our turning point. And then we see that it starts increasing again. So it starts increasing. We hit -1, 1. That's our next turning point. It decreases again, so that we're now going back towards the origin. We increase one more time to 1, 2. Decrease one last time to 2, -3. And we increase for the last time towards infinity, right? This is permanently increasing, and we know it's permanently increasing because the arrow tells us that it's going on forever in that direction, so it's never going to come back down. It's just always going up, so it's always increasing from that point. Okay? So now our task is we have to put this all together. So the way I kind of tried to explain it in the lecture video was try to tackle instead of doing this in each, separate piece, try to do well, you're going to have to do it in separate pieces, but try to do it instead of reading it from the left to the right to all of your matching arrows. Think of all the places that are increasing and then all the places that are decreasing. So because decreasing is happening first, I'm just going to start there. So I'm going to go ahead and abbreviate decreasing, DC, and we're going to have intervals here. So the first interval is we see that it's decreasing starting from the left, right? And again, we're talking about X values. This is where I went on autopilot in the lecture video and made a mistake. So I just want to reinstate this. We're talking about X values when we're talking about our intervals over which the function is increasing or decreasing. So as far as X values are concerned, that means we're reading this from left to right. So even though the function is going on forever and it looks like it's going upward, there's obviously an X component to that. And notice it's better shown on the picture, but there is obviously an X component moving to the left if that arrow is going diagonally, right? It's not just going straight up. It's not a vertical line. So there has to be an X component, which means that it is going to -infinity for as far as our X is concerned, right? So we know that we're starting from -infinity. And again, I told you guys when we first started discussing this, don't necessarily get hung up on parentheses or brackets when we're talking about increasing or decreasing. In this case, because we're starting from infinity, we know that we would use a parentheses anyway, but don't worry about that. Just use parentheses for, labeling these intervals decreasing or increasing. So we go up until we hit from -infinity. It goes all the way decreasing until we hit -3, right? At -3, we see we have a turning point. That's when, things start going the other direction. So we have from -infinity to -3. What's the next point that we're decreasing? Well, the next point is this turning point here at -1, 1, right? So right here, we see that it stops increasing there. And at -1, when x is equal to -1, then it starts decreasing again. So we see that we have -1, and it continues to decrease until we hit the origin. So from -1 to 0. Well, that's not the only time. There's one more time that this decreases, and it decreases once more at this pivot here at 1, 2. So we see that we're starting at x is equal to 1, and it continues until x is equal to 2. This point is our last pivot, right? So it goes from 1 to 2, and this would be all of the intervals in which your function is decreasing. So all you have left to do is just describe the other intervals, because it's pretty easy to see there's no constant area here, right? We have increasing, we have decreasing, we have no lines. We have no horizontal lines. So if there's no horizontal lines, then there's no place where this is constant. So if we already showed everywhere that's decreasing, we just now need to show everywhere that's increasing. So that's going to be the other arrows. So increasing, again, we're talking about x values here. So where's the first place that this starts increasing? Well, the first place that it starts increasing is at the first pivot, right? Which is -3, -2. So that means we're starting from the x value, -3. This continues all the way up until we hit the pivot up top, which is -1, 1. So it's from -3 to -1. And now, before I continue, you might start to see some similarities here. What's going on here? Well, what's going on is we're talking about the interval that's between these two intervals, right? And how would you describe that? Well, you would describe that with the endpoints, which are -3 and -1. So notice that when one interval stops decreasing and then you have the increasing, and then if it starts decreasing again, it's just going to be, each interval is going to be described by the other two intervals on the outside of it. So because we were decreasing from -infinity to -3, and then once again from -1 to 0, and we were increasing between that, well, it should make sense then that the endpoints are going to be similar. So we have -3, -1, right? That's just describing this area here. Okay, so now we have to once again describe the next point. So the next part that it's increasing is going to be this arrow right here, and that's starting from 0, and it goes from 0 up until we hit x is equal to 1, right? Our x value here is 1 for that ordered pair 1, 2. So we're going to have the next one, which is from 0 to 1, which once again, notice, look at this, we see, oh yeah, it's our endpoints from the intervals that were decreasing. And last but not least, we have the last piece, which is this one. So we see that we're starting when x is equal to 2 from this ordered pair. This point is when we start to increase. So we're going from 2, and then because it doesn't stop, it goes on forever. We continue to increase for all of our possible x values. It's going from 2 to infinity. So 2 to infinity. And that's it. So we see that we have 3 intervals for each. And again, you can think about it as the interval between them is going to be the flipped version of it, right? So between two decreasing, so if I'm talking about these two decreasing ones, we see that we have one interval of increasing. And then same goes for between two intervals of increasing, we see that we have an interval of decreasing. So it should make sense that some endpoints are going to be shared between the different intervals. Okay, so if there's no questions on this, I'll take a break for 10 seconds here. Are there any questions on this before we call it a day? Okay, so I know that it's just past 11:50, so we will end class today. I know that a lot of this was a little bit more abstract than normal, not a lot of computation. This was really just about graph reading. So once again, office hours today, 4:15 to 5:15, and I will also have office hours tomorrow from 4:15 to 5:15, so please make use of at least one of them if you need it. Have a good day, guys. I will see you next time, and I'm also ending the recording here.